Okay, so one more time. 51% of people own a dog. If you pick two people at random, what's the probability that they both own a dog? So the main thing, in fact, let me just rewrite it here. So 51% own a dog. If you pick two people at random, what's the probability that they both own a dog? So let me ask you this question. Is this an or is it an and? Which one is it? Is that an or question or an and question? Because that's the big difference, huh? Remember how we learned that or is always add, and what's and? It's always multiply, huh? That was a lot of what we went over last time. We're going to hopefully solidify that for you tonight. Or is always add, and is always multiply. So both owning a dog. Does that mean the first person owns a dog or the second owns a dog? No, it's and, huh? It's clearly and. So what does that mean I'm going to do? I'm going to multiply. What am I going to multiply? 0.51 times 0.51. Exactly. Right? And so I don't know what that comes out to be. Is that it? 2601. And we're done. Is that good? Does that make sense? Does that feel right also? Right? If there's about a 50% chance that somebody owns a dog, there's going to be a lower chance that you'll find two people in a row that own dogs, right? That's less likely that they both own dogs. Does that make sense? You have math feelings. I want to get you in touch with them. You sense that, don't you? You sense it's got to be lower. So like on a multiple choice exam, if there was like an option that said 0.73, you would just laugh at it, right? There's no way it can be higher than 0.51, right? If the chance for one person to own a dog is 51%, then the chance for two people to both be dog owners has got to be lower than that, doesn't it? Can't be higher, right? So it makes sense. The answer's got to be lower. That's reasonable. All right. Okay, so it's saying what's the probability that somebody's a female and got an A in the class? So basically, here's some results from a test. And they're saying if you grab somebody at random, what's the probability that they're a female and got an A in the class? So is this chart, first off, making sense? Like, tell me about these 8 people. What do we know about those 8 people? Males who got an A on the test. Right? And these 10 people, males who got a B on the test, etc., etc. So let me give you a chance to do that one. It's an and. All right, so what? Somebody got it? What are we going to do? Are we good with that? Zach, how you knowing that?
Because females with A's are 2, and 71 total.
Yeah. Beautiful. Right? Probability always has total on the bottom, doesn't it? For all probability, like rolling a dice, 1 out of 6, flipping a coin, 1 out of 2. And on the top is the number of people that are female and A. That's 2 people. 2 females got an A. So there's 2 people in the class that are females who got an A out of 71. Do they want a fraction?
No, the fractions will start to like 15, I think.
Is that what it is?
I think so.
Okay. So we good? All right, so 13. Large population. 70% of the people have been vaccinated. If 3 people randomly selected, what's the probability that at least one? Did we do this one? Sounds
There's a couple of them that are like that.
Huh? Some say yes, some say yeah. They're kind of similar, aren't they? They're pretty similar, yeah. So let me lay out a game plan for at least one. Let's think for a second. If I tell you I have at least 1 coin in my pocket, you know what that means, right? That means I have 1 or 2 or 3 or more, huh? And so what's the opposite of at least 1? Yeah. Isn't the opposite of that 0? If somebody says, hey, Mr. Aaron, do you have at least 1 coin? If I say no, that means I got none, huh? So what my point in that is when you get in at least 1 question, here's the game plan. First, find the probability of none. This is the opposite, right? The probability of 0, that's the opposite of at least 1, isn't it? So the opposite of having at least one coin is having no coins. So find that, and then when you have the opposite, how do you get the real answer? Yeah, the real answer will be 1 minus the probability of none. Because the opposite's always that way, huh? It's 1 minus. Does that make sense? If it's 20% chance of rain tomorrow, 80% chance it won't rain. If there's a 0.2 chance of rain tomorrow, then 1 minus that is a 0.8 chance it won't rain. We good on that? Is that making sense for the at least? This is what you do for at least 1. You find the probability of none, and then you take 1 minus that. Because at least 1 is the opposite of none. All right, so let's get back to it. The question is, 70% have been vaccinated, 3 people, at least 1 vaccinated. So here we go. Question 13. 70% of people are vaccinated. Might be 2 C's. Are 2 C's in vaccinated? Yeah. Are vaccinated if we randomly select 3 people. What's the probability at least 1 is vaccinated? So there's the question. All right. So how do we find the probability of none on this one? Probability of none. So none vaccinated. And we're talking about 3 people, huh? So for none to be vaccinated, we'd have to have the first not vaccinated times the second not vaccinated times the third not vaccinated. Is this making sense? We're selecting 3 people at random, and we're finding out what's the chance that the 3 people we select, none of them are vaccinated. Well, that would mean the first, second, and third are all not, right? Not vaccinated, not vaccinated, not vaccinated. And what's the chance that the first person is not vaccinated if 70% of the people are vaccinated? 0.3, right? Times 0.3 times 0.3. This making sense? Because if the chance of rain tomorrow is 0.7, then the chance it will not rain is 0.3. Right? So if 70% of the population is vaccinated, then if you grab somebody random, the chance they're not is 30%, or 0.3. So the chance the first person is not is 0.3, second 0.3, third 0.3. So multiply those together, and you'll get the probability that none of the 3 are vaccinated, which is the opposite, and then we'll need to go 1 minus. So that's going to be 0.027, isn't it? Probability of none is going to be 0.027. So then the probability of at least 1 is 1 minus that, because that's the opposite, 0.973. 0.973. Are we good with that? That making sense? 0.973, how are we doing? Questions I can answer? All right. So number 11. So probability, male or got an A. So they're saying probability, male or got an A. So what do we do? Male probability is always a fraction that has the total on the bottom, huh? We know that much. That's always how probability goes. And on the top, you've got to have male or A. So, okay. So the total, that's easy. That's 47, right? That's the total. 47. That's the denominator. So what goes in the top then? All the ones that are male or got an A. How many is that? How do we find that? Yeah. Najwa? Almost. So tell me. Let's make sure we're clear on these people. Tell me about these 13. What are they? Males that got an A. What about these people? Males that got a B. What about these people? Males that got a C. Those are all males, right? So they should all be in. In fact, we could have just grabbed that total right there, huh? That's the total of all the males. 23 plus, but that's not they didn't just say we want the males. They said we want everybody who's a male or who got an A, which means we're also including the females who got A's. And that would be 2 more. Does that make sense on that? So 25 over 47. And they just want a decimal on this one? Yeah. So just divide with calculator. Get a decimal to 4 places. We good there? All right. So, good. So let's move ahead. So number 12. So we have grades and gender. So this one student is chosen at random. Find the probability the student was a female. So that's going to, again, be over the total. Female, so what's the female? 30. That good? 30 over the total. 30 over, 55. Do they want decimals on these or what? Oh, round the answers. So just hit the buttons on your calculator. Next one. Male and got an A. Again, it's over the total. All right, so over 55. Male and got an A. So where's that go? How many is that? Just 3, huh? We good? Then divide them on your calculator. That's good. I don't mean to whip through these. Let me know if you want me to slow down on these. Okay, and if you have other questions. Next, male or got a C. That's going to be out of 55. Male or got a C. So the or is always a little more tricky, huh? What are we going to do?
25 plus 8.
Right, good. Male or got a C. Yeah, 25 plus 8. Which will be like 33 out of 55. Hit the buttons on your calculator. I think it's 0.6. So is that good there? Does that make sense? The ors are more tricky, huh? So I took the male total. That's the total of all the 3 males. And then the additional females that got a C. Does that make sense? That's all the people that are males or got a C. Right? If you could do it individually if you want. You could just add those 3 up and that one. That'll be the same thing. Right? Those are all the males and people that got C's. So everybody that was a male or got a C. Finally, D, in one student, if one student is chosen at random, find the probability that the student got a C. Oh yeah, that's a good one. Yeah, let's talk about D. D's tricky. Yeah, and that's what we're going to get into today. So it's good that I kind of precursor it. It says the word given. That's a good question. So given, what does given mean? What does given mean? Think with me for a second. What if I roll a die? What if I roll a die and I say, hey, tell me what's the probability that I'm going to get a 6? If I up here and I roll a die, what's the chance I'm going to get a 6? 1 out of 6. Now, what if I tell you, what if I roll the die and I say, hey, what's the chance I got a 6? You'd say 1 out of 6, you'd be right. But what if I say, hey, I'm going to give you some information. I did get a number higher than 4. I did get a number higher than 4. What if I say, given that the number is more than 4? What if I give you that information? What if I roll the die and I say, hey, I rolled the die and I'm going to give you some information. The number's more than 4. It's more. What does that mean the number could be? If the number's more than 4 that I just rolled, what could it be? It's a 5 or a 6, huh? It can't be 1, 2, 3, or 4. It's more than 4. So, what's the probability that it's a 6? 1 out of 2, huh? Right? You sense that, don't you? You don't need me to tell you some math rule. You just smell it, don't you? You sense it. You have math feelings, right? I just got to get you in touch with them. You feel that. You know that. By the way, notice probability is about knowledge, really. You ever thought about that before? I think probability is very interesting. Probability is about knowledge. In other words, when I rolled the die at first, there was a 1 in 6 chance I was going to get a 6, huh? But when I gave you a little more knowledge, and I said, hey, by the way, it is higher than 4, that changed the chances, didn't it? That knowledge changed the chances. That's what we're going to do a lot of in the next section in about 15 minutes here. That meant there was only 2 things it could really be. The denominator changed. So whenever they give you information, that limits the possibilities, doesn't it? Limits the possibilities. That's why insider trading is illegal. What in the world am I talking about? Martha Stewart. That's why she went to jail. Why? What am I talking about? Why is insider trading illegal? What does that have to do with probability and knowledge? You making the connection? If you're an insider to a company, if you know that they're about to make a move that's going to make their stocks go up or something, you're not allowed to trade with that company on the fair market because it isn't fair. You know stuff other people don't know. You have knowledge. And so the probabilities are different for you. It's like somebody telling you, hey, I don't know if you should invest in that company or not. I don't know if they're going to go up or down. And then somebody says, hey, I'll tell you this, it's a 5 or a 6. And you're like, oh, all right, I'll invest. See, that changes the game, doesn't it? When you're an insider, that unfairly changes the game. That's why it's illegal. They got to make it fair for everybody. So probability is about knowledge, isn't it? It's always about knowledge. What's going to happen is going to happen in the future. Things aren't truly random. I'm getting all philosophical here. But really, nothing is technically random. What's going to happen is going to happen. We just don't know. So to us who don't know, it's random, right? It's a statement of our lack of knowledge, really, in the end, isn't it? Getting all metaphysical here in math class. But it's true. That's what probability really is. It's probabilistic knowledge. So when they give you a given statement, they're giving you more knowledge that limits the possibilities. So getting back to this question then, they're giving us the information. They're saying, what's the chance the person got to see given they're a female? So they're saying, hey, we're given that it's a female. So just what that means is, just forget about the males. They're out, right? We know that it was a female. It limits so the total's not going to be 55 anymore, is it? Or whatever that was. That's out. That's not even a possibility. In fact, what is the denominator now? Yeah, it's the females, which is 30. Yeah, total females 30. See how that limits the possibilities? They're giving us the information that it was a female. And what's the chance they got to see? So that'd be 8. 8 out of 30. Does that make sense? That's a lot of what we're going to do tonight is given. Given limits the possibilities. It changes the denominator. Good there? Questions on that one? All right, so here we go. The pedestrian, driver, intoxicated thing. What's their question? Find the probability that the pedestrian was intoxicated. So probability, pedestrian, intoxicated. All right, so you know what goes in the bottom is the total always. So I don't know what the total is. You just got to add all those numbers up. And then pedestrian intoxicated, what number is that? Pedestrian intoxicated. Oh, yeah, it's these two, huh? It's both those two added together. So pedestrian intoxicated. That would be 56 plus 226. Both those groups are, the pedestrian is, yes, intoxicated. Whether the driver was or not, we don't care. We're just saying pedestrian intoxicated, both those are, yes, pedestrian intoxicated. You have to add those up over whatever the total is. Oh, yeah, thanks. There it is right there. I don't need to add those up. It's there for me. 986. And hit the buttons on your calculator. We good there?
Yeah.
Makes sense? All right. Same kind of question. Probably that both the pedestrian and driver are intoxicated. Probability both intoxicated. It's always going to go over the total. Both. How many cases were both intoxicated? That's easier actually, right? 53 over the total, just like that. And did they put the total at the top up there? Yes, they did. 987. Hit the buttons. Easy? It's getting easier? Najwa.
I didn't know about
16.
16.
Good, so let's do 16. And I'll show you about the calculator. Fractions. All right. Well, I guess I unplugged or something. Oh, okay, so a jar contains 8 red, numbered 1 through 8, 10 blue, 1 to 10. So the red are 1 to 8, and the blue, and 10 more 1 to 10. Okay. A marble is drawn at random from the jar, blah, 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 blah. Okay, so here comes the first question. What's the chance that the marble's red? Let's start there. So if you're going to draw it, here's what's in the jar. Got 8 red marbles and 10 blue. So probability always has the total at the bottom, and in this case, red at the top. So how many red marbles? 8. How many total marbles? 18, right? Because there's 10 blue and 8 red. Now, they want a fraction answer. 2 things you can do. So let me show you. So on your TI calculator, if you go 8 divided by 18, 8 divided by 18, and hit enter, you'll get a decimal. I don't know what that is, for whatever it is. I think it's 0.4444 forever. You'll get that decimal. Now here's what you hit to convert it to a reduced fraction. Hit math. Hit the math button. That's a button on the left side, third down on the left. Math, and then just hit enter twice. You'll see what pops up on the screen is change to fraction. You guys with me? So go ahead and go 8 divided by 18. Hit enter. You'll get that 0.4s forever. And then hit math, which is the left side, third one down on the left side. Math enter on the TI 83 or 84. And it'll automatically change it to, 4 ninths? To 4 ninths for you. It'll reduce it automatically. That's all you got to do to change from a decimal to a fraction is math enter. That changes any decimal to a fraction. Those TIs are great. They'll do everything. Short of speaking to it, solve my homework. Other than that, it does a lot of amazing things. We good there? Everybody catching me on that to save time and effort? So on all those ones where they want reduced fractions, you can just do that. Now, if you want, you can do it by hand. You could just say, well, I'll just divide by 2, then it's going to be 4 9. Same answer. You can do it by hand.
Try that on the next one.
Yeah, is the next one awful?
Stupid numbers,
Yeah, so if you get an awful one, for sure, calculator.
The 2 dividing.
Yeah?
That's only like 20 minutes.
Oh, yeah, you don't want to do that. Yeah, sorry, I didn't realize they had fraction ones till half of you left. Odd. So what's the probability you're going to get an odd number? Again, the total's on the bottom. Total's 18. How many odd numbers? Well, there's going to be, for the red, there's going to be 1, 3, 5, 7. And for the blue, it's going to be 1, 3, 5, 7, 9. So 9 of them, huh? Does that make sense? And that's just going to be a half. You can hit the buttons on your calculator. That's just a half, isn't it? All right, let's jump down to part C. We good there so far? So I'm going to get a fresh screen. Whoop, not that one. Right here. So part C. Red or odd. Red or odd. So again, it's over the total. Red or odd. So let me write it up here again. What is it? Red 1 through 8. Okay. So it's red 1, 2, 3, 4, 5, 6, 7, 8. Oh, I missed 6. And then blue 1 through 10. I'm just going to write them out. Okay, so and what do we want? We want red or odd. So how many is that? It's all these red ones, and then this, and that. Those are all the ones that are either red or they're odd. Is that making sense? There's 8 red ones, and there's, what is it? 1, 2, 3, 4, 5 blue odd ones. So yeah. And the total is 18? Yeah, 18. So that's going to be 13 out of 18. And that fraction doesn't reduce. Just leave it that way, 13 out of 18. Does that make sense how I did that? Red or odd. 8 red ones, and then 5 more that are odd, even though they're not red. Final one. Blue or even. That's going to be the same thing. How about I move on? So that's the same kind of thing, right? Grab the blue ones, grab the even, other ones that are even. Do the same kind of thing. Use your calculator. If it comes out ugly, math, enter, change it to a fraction. All right, there it is. So if you're going to roll a die 4 times, what's the chance of getting a 2 on every roll? Getting a 2, and a 2, and a 2, and a 2, right? That's an and question, isn't it? 2 and a 2 and a 2 and a 2. So what does that mean we're going to do with those probabilities? Add them or multiply them? Multiply them. And is always multiply, huh? So what's the probability of getting a 2? 1 out of 6 times 1 out of 6 times 1 out of 6 times 1 out of 6. Because the chance of getting a 2 is 1 out of 6. And we want that 4 times in a row. So we multiply those together, right? And probabilities always times, don't they? Is that making good sense? So now how do you multiply those fractions? Just take your calculator out and literally go 1 times 1 times 1 times 1. And on the bottom, 6 times 6 times 6 times 6. You'll get some big number. I don't know what it is. Let's see. The bottom comes at 1296. The top is just 1. And then divide that in your calculator. And I'm getting some decimal, which is... it comes out weird. Yeah, let me explain. I see. Maybe that's getting you. Yeah, did you guys get this decimal here? Did you get... what is it? 7.716, blah, 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 blah. E minus 4. I don't know if I've explained that. Did we talk about that? It means, anybody know? What does that E minus 4 thing mean? Nope. It means take this decimal and move it back 4 places. It's scientific notation. So that minus 4 means the decimal doesn't really go there. It goes back 4 places. So here we go. So we're going to get that a lot throughout the course. Everybody with me? Everybody see it? So if you get this kind of an answer on you, it's going to definitely happen in different things we do throughout the semester. If you get this E minus 4 thing, that means the E stands for exponent. It's scientific notation. Anyway, whatever. We need to move it back 4 places. 1, and it's to the edge. 2, 3, 4, those all bring in zeros. So the real number is 0.0007716. And we got to round it also, which I'll do in just a second. But is everybody good so far? Does that make sense what just happened? So when you get that E minus 4 thing, that means move the decimal back 4 places. If that was the E positive 4, it would mean move the decimal right 4 places. So whatever comes after the E means move right or move left that many places. Najwa.
Okay, so where it says, what is the probability of showing, mine says 5.
Showing a 5 on every roll? Yeah. So what's the chance of getting, good question, what's the chance of getting a 5 when you roll a die? Exactly the same. Right? Isn't the chance of getting a 5 1 out of 6, just like the chance of getting a 2? It's just one result out of 6. Yeah, so it doesn't matter what number they put there. That's just one of the 6 possible numbers. Is that good? Is that everybody okay with the E thing? So it just goes back 4 places. The first jump went to the edge of the 7. The other 3 jumps beyond the edge brought in zeros, right? Like that. Now, here's a little trick. If you don't want to do that, what you could do, if you guys have this on your calculator, if you get this 7.77... no, I'm doing it wrong. Here's a trick that you might prefer. Just, you get the E minus 4 thing. Just add 1. Just go plus 1. And what it'll do is it'll force it to write it normal for you. It'll put a 1 in the front, and then you just ignore the 1. It'll make it like this. It'll go 1.0007716. It'll force it to be written normal-like. So that's another thing you can do. You can just add 1. And it'll make it look normal, if you prefer. If you don't want to just count it yourself. on that. Question?